This video covers Newton's second law of motion. Newton's second law of motion gives us the equation net force equals mass times acceleration. This equation means that an object's mass times its acceleration is equal to the amount of force being exerted on the object. Net force is expressed in a unit called a newton. A newton is the same as a gram, the unit of mass, times meters per second squared, the unit of acceleration. To approach a Newton's second law problem, there are 4 key steps we need to follow. Number 1, draw a free body diagram. This allows us to see the forces and which direction they are moving in. Number 2, find the net force in the x and y directions. Number 3, choose the net of x or the net of y equation, whichever one has the unknown variable that you would like to solve for. And number 4, solve for the unknown variable by setting your net of x equation or your net of y equation equal to mass times acceleration. Alright, so here's an example. Jerry is on the highway and his car runs out of gas. He decides to get out of his car and try to push it to the emergency lane. The mass of the car is 1,000 kilograms. The car is accelerating at 0.5 meters per second squared. If the friction static force is 45 newtons between the car and the ground, then what is the push force Jerry is exerting on the car? Alright, so here are our steps that we're going to use to approach this problem. Just a quick review of them. And here we go. This is Jerry pushing his car to the emergency lane. Our known variables. The car is 1,000 kilograms. The acceleration of the car is 0.5 meters per second squared. And the friction static force is 45 newtons. The unknown variable, the push force. Number 1, draw the free body diagram. We know there's a normal force on the car because the car is touching the ground. We know there's a weight force because the car is on Earth. We know there's a friction static force between the car wheels and the ground of 45 newtons. And we also know that there is a push force that Jerry is exerting on the car to get it to the emergency lane. So, we find net Fx, which is the push force minus the static force, because the push force is in the positive direction and the static force is in the negative direction. The net force in the y direction is the normal force minus the weight force, and again, because the normal is moving in the positive direction and the weight force is the negative direction. Then, we choose which equation we would like to use. The question is, what is the push force Jerry is exerting on the car? And so, because the push force is in the net Fx equation, we are going to choose to use net Fx. So, we set the net Fx equation, F push minus F static, equal to mass times acceleration. Then we solve. F push minus 45 equals 1,000 times 0.5, because 1,000 kilograms is the mass of the car, and 0.5 is the acceleration of the car. When we solve this, we get the push force is 545 newtons. In summary, Newton's second law problems can vary because the questions that are given on a test or a quiz or a worksheet can give different variables. However, the 4 key steps and the key equation of net force equals mass times acceleration are always the way to approach the Newton's second law problem. Also, remember to be aware of which equation you're using, net of x or net of y, because you always want to be aware of which variable you want to solve for. Thank you.